Steve, welcome to the show. It's a pleasure to have you on the podcast today.
Thanks, Andy. Yeah, thank you for inviting me on, and looking forward to having a good chat.
Yeah, of course. And just to begin with, can I get you to go through your background? Obviously, there'll be a lot of people that have heard of you, but just in case it's someone's first encounter, if you could walk us through, I guess, your career and where you are today.
Yeah, absolutely. So I currently main role is senior lecturer based at Sheffiled Hall University in the UK. So I've been in this role for, in fact, I was working out with a colleague just today that we're coming up to 10 years as sort of lecturers at the university, which is quite a nice milestone. But alongside that, certainly throughout my time at Sheffield Hallam, I've done a number of different things. Completed a PhD specifically in low velocity profiling VBT. Um, Undertaken a number of different consultancy roles within football. We've got a kind of a long-standing contract with British Diving, whereby we've just had some successful medalists at Paris, which is really cool. And worked across a number of different sports through different sort of relationships we've built through the university. Alongside that as well, obviously a practicing sort of early career researcher, so post PhD now for a couple of years, and sort of still researching in different areas, a little bit in VBT, but also in other areas within sort of S&C, sports science, and a broader kind of physical activity realm.
Cool. And obviously, the big kind of topic we're going to hit today is going to be velocity-based training.
Yeah.
I guess to set the scene, I'd love to know how you became aware of it and what your sort of initial route into becoming interested in using it was.
Yeah, it's good, interesting question, I suppose, in the sense of when I first started within academia, I was a technician, and I kind of moved into a part-time lecturing role when S&C was very much a new topic within university degrees. And at that time, I was interested in doing a PhD, and I was simply trying to find a topic that interested me. And this will have been back in 2015, 2016, something like that. VBT at that point was emerging as quite a new and interesting area within strength and conditioning, testing, programming, etc. And it just sparked my interest. I started doing some reading. We managed to acquire some different technology and started playing around with it, and sort of started to build a real interest in the area, in the topic. And then obviously kind of forged that into a PhD, and kind of the rest is history in terms of being able to utilize through all sorts of different work, whether it's teaching, research, consultancy, coaching. There's always some kind of element of VBT within that. And from my perspective, it's a really valuable tool, and a really, really diverse, flexible tool that can be used in many, many different ways.
Yeah, absolutely. And we had Chris Toombs on a couple of times over the last few years that we've had this show, talking about velocity-based training. However, it's definitely been a while since we had his last episode. There's been a lot of articles out in recent years around profiling, velocity loss, and prescription. Can you kind of get us up to speed? It's been a good few years since we had Chris on, but I'd love to just know where the sort of current lay of the land is with velocity-based training research and application.
Yeah, like you said, there's been lots. There's hundreds and hundreds of papers out there now on different elements of VBT. I'd say the main two topics is profiling, so low velocity profiling, whether that's just simple profiling or utilizing some form of 1RM prediction, and then something around velocity loss. So really, the developments, I suppose, have come in our understanding of kind of the underpinning principles and theories of the different applications within VBT, specifically those two, and then the applied nature of them. So, from a profiling perspective, it could be anything from different ways to construct the profile, utilizing different number of lows, different number of data points, different statistical models, utilizing those approaches to predict 1RM or to potentially not predict 1RM, which whilst this doesn't necessarily come out from the research, certainly my own learnings of VBT, and ironically my PhD centered around 1RM prediction through load velocity profiling. The more I researched it, the more I tried to implement it, the more I kind of came to the conclusion that perhaps it's not all that necessary if you do some of the simpler approaches to profiling and load management, load manipulation. If you can do those simpler options well, the 1RM prediction perhaps is a step that isn't necessary, or we can get away with not doing it. And the reason I say that is because to get it right it can be difficult. It's a challenging thing to do. From a kind of a data quality perspective, you have to get reliable data. That can be troublesome and can be challenging if the individuals you're working with are not necessarily well versed in velocity-based training, i.e. maximal intent and velocity at light loads. That can often be a sticking point because that might throw off the profile and therefore your predictions become way out. But also from a logistical perspective, to really use 1RM prediction, you have to be doing it every session because that's the point. We re-predict our 1RM to recalculate our loads session by session. That's time consuming. Being someone who's worked worked mainly in team sports, we don't have that luxury to profile every session because typically you've got a 45-minute session. You've got 15 athletes in an S&C space, and you're the only person perhaps with one or two devices. It's very difficult to do that. So my viewpoint on that aspect, and I know we're kind of diving straight into the detail, which stop me if you don't.
That's good.
My take on that is actually if we do a simple profile at the start of an intervention, just like we would typically do a pre-post test of an intervention. Most S&C coaches would do some form of strength test, 1RM for example. The low velocity profile is no different from a 1RM. We work up to 100% maximum on that day. Hopefully it's a true reflection if, appropriate rest and all those kinds of things that we would put in place to make sure the testing is valid. If we collect that data, we do some sensible increments from anywhere from 30% 1RM up to 100 in maybe say 10 or even 20%, then what we have there is a clear profile. We have kind of velocity versus load, whether that's absolute or relative load, and we have that sat on a figure, on a graph. We then apply our regression model. Some would say it needs to be linear. I would argue it actually probably needs to be like a polynomial. So a second order polynomial is basically a curved line that you would put through the data. Because I don't think, certainly in my research and other research, certainly in free weight lower body exercises, which is where I think VBT has its biggest bang for its buck, I think there's emerging arguments that actually it might not be quite linear, so maybe a more sophisticated model is better. But essentially, once we have that curve and we have load on the X and velocity on the Y, all we need to do is figure out what load we're going to do for that day, go up to the line, go across to the Y-axis, figure out what that velocity is that represents that load, and then create a sensible boundary around it. So it could be plus or minus 0.03, 0.04 meters per second, for example. That gives us our zone. We then simply task our athletes to figure out what load should be on the bar in order to keep them within that velocity zone. If they're a few meters per second out, 0. Whatever meters per second out, we add a little bit of load on if they're a bit fast. If they're a bit slow, we take a little bit of load off. And it becomes a bit of trial and error. But what it does do is it allows us to do everything live within the session. So we can be adaptive, we can be flexible. If, for whatever reason, the first set goes really well and there's some residual fatigue that only comes out after that first set, velocity-based training or having some kind of velocity device like output, for example, on the bar would allow you to make those load manipulation and those adjustments in a really, really simple, crude way. Now, yeah, there might be researchers out there that are sort of saying, well, that's not the way it should be done, because that's kind of not the true aim of a load velocity profile. We want to extrapolate and we want to make it accurate and we want to do it to the nth degree. But, practice isn't like that. The applied world is bound by logistics and bound by challenges. And, we have to, the whole point of our research as academics, in my opinion, is to inform practice and make practice better. So there's no point in doing stuff in a lab that isn't going to work in the real world. So.
Obviously, a lot of that is kind of speaking about velocity-based training in a more traditional way, maybe with barbells or free weights. How much sort of utility have you had or played around with in terms of maybe using fixed machines? This is something that I've been doing more recently, if kind of ecologically I've been working with an athlete in a setting where, for whatever reason, I don't have force plates or other tech, and I've sort of used a velocity-based device as kind of like, poor man's surrogate for rate of force development.
Yeah.
Similar to kind of Alan McCall of what he does on the leg extension as a sort of poor man's IKD. Mm-hmm. How much do you how much have you used it in a machine-based way?
In truth, it's not something I've typically done, only because I've always had the luxury of having, nice shiny S&C suites with lots of racks and bars, and I've not needed to do that from a velocity-based perspective. Outside of VBT, I've had to do all sorts of weird and wonderful things to get the stimulus into the guys I'm working with, but there is no reason why it shouldn't and wouldn't work. It's exactly the same principle. It's moving a fixed, or it's moving a load in a relatively sagittal plane, with regards to the device, a vertical plane of motion as well. Even on a 45-degree leg press, you still set up the device as if to tell it it's going straight up, whatever that device would be. So absolutely no reason why it can't work and it wouldn't work. And I believe there are small pockets of research that have done that and have shown comparable results to any kind of free weight or Smith machine-based exercise, be it squat, deadlift, bench, whatever.
Yeah. And obviously, you work in academia, so I'm sure you've been involved in lots of projects and lots of papers, but what was the kind of main focus of your own thesis for your PhD?
So it kind of moved, as most PhDs do, as you kind of work over 5 or so years. But for me, mainly it moved because of COVID, because I was 2.5 years in or 3 years in, and then we all went down to lockdown, and I was just about to start some relatively big intervention study, and that all got halted. So I was able to kind of manipulate the direction of my PhD, put the right boundaries in place from a kind of PPE and protective perspective, and we went down the 1RM prediction route. So we kind of did a series of studies that looked at some reliability of equipment, looked at just simple cross-sectional analysis of load velocity profiling in a back squat and in a power clean, because at the time there was nothing in any kind of weightlifting derivative, which we felt was an important thing to explore, and then moved into looking at a kind of a new way of predicting 1RM from a different model. So mine was a combination of a few different things. Firstly, combining ballistic and non-ballistic exercise. So if you think, let's take the back squat as the example, because that's what I used, you would typically do anywhere from 20% 1RM to 100% 1RM in a non-ballistic exercise, so in the back squat. That for me had a couple of flaws. The first is familiarizing and habituating individuals, no matter how trained they are, lifting 20% 1RM in a back squat at maximal intent is very difficult. There is variability in there, basically because of that decelerated phase you get at the top of a non-ballistic exercise when it's a light load. In order to not leave the ground, we have to slow the bar down, sort of intuitively, and that can be create some variability in the velocity data. But the more important aspect from my perspective was, why are we getting individuals, athletes, to test at loads in exercises that they would never use to train? We would never prescribe 20% 1RM in a back squat, but we might prescribe 20% 1RM back squat in a squat jump or a jump squat, like a loaded jump squat. So I kind of felt like, well, let's combine the two and let's look at does that create a more robust and reliable profile, and therefore improve the ability to predict 1RM, because we know that those data points are going to be closer to the model line that we put through and have a stronger predictive equation. I then combine that with a slightly different method of extrapolation. So instead of going to 80% 1RM and then using the velocity data to extrapolate down to 100, I actually predicted 80% and then just took that down to 100%. So I used velocity to predict a load that we previously found was definitely reliable, whereas 100% 1RM has been shown to be unreliable from a velocity perspective. So we found the heaviest load from my own PhD data that was definitely reliable, predicted that, and then extrapolated down to 100 to get that 1RM prediction, to which both methods were pretty accurate. We had sort of, I think, 1 or 2% out in terms of that prediction. So I was really happy with it. I was really happy with that direction and kind of the findings and what that meant. It didn't make my practice any easier. I'm not going to lie to you. Because it was a very invasive, time-consuming process. It was very much a lab-based process that looks great in research, but would I be able to do that at the start of every session? Absolutely not. It just wasn't feasible. So, learnings from that whole process, certainly from an applied perspective as to how well that approach actually would work in the real world.
Is there anyone that's kind of, since you completed that, taken your work and kind of run with it and taken those ideas further?
Not that I've seen. I would love somebody to do that, or I would love to do it myself. I've tried to set up the odd student kind of project in that way, but it never works out in the way that you would hope when doing something like that. So, I'd really like to expand that into different exercises. I'd really like to explore kind of a bit more of an iterative profile, whether we can create a reliable profile from training data as opposed to that one-off testing session. A device like Output, which I use quite frequently in some of the consultancy that I do, it is possible to do that. So one of their in-app or sort of platform solutions is it will find you your most recent, most appropriate sort of profile based on training data that you feed into it, which I think is a really cool way of doing it, because it takes away some of those logistical issues that I'd already mentioned in terms of having to do it at the start of every session, it being a fixed testing protocol, and we can make it a little bit more iterative. So some research around that I think would be really cool as well, because that would potentially solve a number of issues, certainly from that 1RM prediction perspective.
I think it's nice as well to, I think the more frequency of data snapshots you get, the easier it is to understand the bandwidth of normative data for any individual. Yeah. I think, my experience Output's great for that, because I can just look through the timeline of any, call it test or training session, any kind of input of data that relates to what I'm looking at. I love that it factors all of it in, especially, because it's the type of device where training and testing are one and the same.
Yeah.
When you're able to use it, versus you're not always going to test on force plates. Sorry, you're not always going to train on force plates. You might test on them. You may not then use them to train. Obviously you can, but you may then go away and do gym-based interventions that don't involve the plates and come back to them, versus I think, Output and these kind of devices give you that utility, which I think is great.
Yeah, absolutely. It's kind of like it's the plug and play option, really, that I think is really important in devices. You know, when I get sort of semi-regularly questions around what's the best device out there, and you know, I try not to hang my hat on anything, but ultimately it's down to that individual to make a decision on what do they need the device for, and there has to be a kind of an agreement, a myriad between good quality data. So obviously there's no point in using a device that has unreliable or invalid data. But then it has to be user friendly. And you know, there are lots of devices out there that tick that first box, but perhaps don't tick the second box as well as they could do. And vice versa, I suppose. There's some really, really easy and sort of efficient devices from a usability perspective, but then falls down with the data. So I think it's important to have that balance between the two. And you know, the easier it is to plug and play, stick it on and get going, which, you know, output is definitely one of those. It makes life a lot easier. And then, as you mentioned, becomes the blurred lines between training and testing become more blurred, which actually is probably not a bad thing.
Yeah, I think for me, like, a lot of my application of using these tools is now in rehab, and I think everyone can relate to the idea that, you know, in pre-season or whenever you do it, whenever you're asking athletes to do their more formal battery of testing, whether that's going to shape rehab or S&C or both, there's only so many tests you can put somebody through in a single session, day or period, and expect them to comply with their full attention and intent.
Yeah.
I think the nice thing for these devices is, yes, you can involve them in your formal assessments, but at any stage in the season or whatever, you may lose this sort of sterility of the data, but you can slap a device on, a leg extension, a leg press, a squat, a jump, whatever it is, and you can get that frequent data that then, if you have got an injured player and during the process you want to kind of understand what their normative standards were on a certain exercise, you're going to get closer, or you're more likely to have that stuff if you've thrown the device on things routinely.
Yeah.
Just to build that sort of library of data. So I think for me, it's the utility there is huge.
Yeah.
And convenient.
Yeah, absolutely. And I think the rehab space kind of within VBT is a really interesting one. And again, one that's probably not really, certainly not researched, but even kind of spoken about that much as other elements of rehab. But, you know, it gives you some real objective data to drive either back towards or to try and get past or whatever. So, I mean, I'm interested because I've never had the opportunity to use it within a rehab space, but you clearly have. So have you found it useful? How have you used it from a rehab perspective?
Yeah, I think for me, like, you know, in an ideal world, say you had, I don't know, an athlete with a knee injury, in an ideal world, you'd be able to look back and see really frequent, high quality force outputs on an isokinetic machine, a force plate, you know, doing calf-based work, whatever it is, you'd be able to find all that stuff because you're doing it all the time. But in reality, that doesn't happen. But let's assume most athletes are going to be in the gym training consistently. I think for me, where it helps is I think I'm the same with Alan McCall, and we spoke about this when he was a guest, is I can put them on the leg press or the leg extension, and I can get really frequent snapshots of improvement and status on the machines or whatever or the equipment that they're using all the time. So I don't have to go from this kind of gym setting where they're using, let's say, a traditional leg extension machine in their normal environment, and then put them in this slightly novel space, a lab, or biomechanics setting where they're then using, say, an isokinetic machine. And of course, isokinetics are higher quality. You can isolate things more. I'm not going to say they're not good. They're fantastic. But I can, on a session-by-session basis, get progress, feedback. I can drive intent from the apps themselves. So it just gives me, again, repeating myself, but it gives me that frequency of matching what they're using and how often I want to get the data from them. So that, I think for me, that's a big value. Yeah. And then if I don't have a certain tool on me, like a force plate, I can still get a sort of surrogate for maximal force expression in some way.
Yeah, absolutely. Yeah, I think it's really it's VBT as a whole, and it's why I love it so much, is extremely flexible. There's so many things you can do with it, but then within those, let's call them applications, it can be even more flexible to mold to a scenario or an environment that you need it to. And I really love that about it. There are certain approaches, technologies, whatever it might be within sports science and S&C that I think are quite rigid. IKD as one, you can do really, really good, cool stuff with it, but it's limited. You have to be in certain situations, certain environments for it to really be useful. Whereas VBT, you can go from simple feedback where it's plug and play. Let's just drive some intent. I don't care what the numbers are. I just want each rep or each set to try and get a little bit faster. And let's educate. Could be working with young athletes. Let's educate them on how to actually move with intent. You can use it to drive to sort of generate buy-in from younger athletes into, I've worked in sort of football for many years, and I've said this numerous times in different sort of podcasts and whatever. There is always a bit of caution with S&C and gym within that environment, and understandably so. I understand it and I get it, and I've got no problems with it. But then it's our job as the physical performance coach to figure out how to work around that. If the players are cautious of lifting heavy loads, well, let's change the focus. Let's not chase the load. Let's chase the velocity. Let's chase the speed. Create some competition. Create a leaderboard. Do it in a way that is relevant and relative to the sport that they're playing. I found that to be very successful, and I know there's plenty of other practitioners out there that have utilised it in similar ways and have found great buy-in. I've been lucky enough to go to some different football clubs and kind of provide some CPD on VBT, and I've seen it in action, how they're using it, and it's brilliant. Like the intent and the environment that can be created from just a simple feedback of numbers of speeds can completely change the environment that those players and athletes are working within. So it can be really powerful, and powerful in a really simple fashion. You're literally just giving them some numbers, and it changes the whole complex of the room. It's really cool.
I think for me as well, it's allowed me to periodize the test or the technology that I use. So same thing with that kind of knee extension example. If you're at a team and you've got an isokinetic machine all the time and you can easily train and test on it, great. You've got maybe the best thing available for that particular exercise, or data that you want to get from it. But I think for me, it's if I can see that, not necessarily trying to create maximal velocity, but somebody during a rehab isn't getting the same range of movement during a loaded knee extension, and I can see that on the device, that gives me feedback that tells me there's no point in me doing anything more advanced in terms of testing yet. I know where they're at for that moment. But equally, if they're not symmetrical or they don't have a good asymmetry percentage when they are trying to create maximal force on that exercise with a higher load, is there any point in me putting them on a maximal eccentric test if concentrically they're just not there yet? So it kind of allows me to stick to my common sense of what you do and when you should test certain things and stress them, but it just gives me a little bit more objectivity behind that common sense, which for me helps. And I think it also, if you're with an athlete who wants to jump ahead in the process at those kind of early to mid rehab phases where you're dealing with those things, I can turn it around and say, look, don't do this yet, and the reason is because we can see here. And it just gives me a nice number graph that I can give the athlete a slightly more concrete reason than just my words.
Yeah, it's confidence, isn't it? And I suppose this isn't true of just VBT. It's any kind of objective data, and actually, I think athletes seem to be more curious and interested in that data, and they actually take an interest in it. So I think, like you said, I'm sure we both develop trust with the athletes that we work, and they would trust us if we say, no, actually, you're not ready for that. They would say, all right, fine. But actually then being able to show, and here's why, here's a graph or here's some numbers to say, this is why, it just provides you with that confidence, and them the confidence in, like you said, in what you're proposing, and sort of to trust that process and that system a little bit better.
I think it's easier to show a number, isn't it, and have like a quote unquote rule rather than a reason that you have to repeat on. You know, a number you can just say, yeah, when you get to that number, we can do this.
Yeah.
If it's not as black and white as that, you can find yourself having the same conversation a few times.
Yeah, absolutely.
You know, I think one of the big focuses we've been speaking about today is true kind of velocity-based applications for these tools. But we know that VBT as a profiling tool has other functions too, or the technology at least has other functions too. What are some ways that you're using these sensors that carry that function, but in other ways?
Yeah, so we've kind of touched on the feedback element. So feedback is massive from my perspective in all of those kind of additional benefits that you want to try and get within a gym space. So intent, buy-in, sort of healthy competition with oneself or with squad mates or whoever. You know, there's a relatively recent systematic review meta-analysis done by Jonathan Weekly, who looked at all of the different feedback research from a VBT perspective and kind of surmised that any kind of feedback, however it's done, on average might improve performance by sort of 8 or 8.5%, something like that. So just by simply putting a device in front of someone and giving them some numbers could potentially improve performance by nearly 10%. And by performance, we're talking kind of, you know, mechanical output within that gym space, so moving the bar a little bit quicker or maybe moving something a little bit heavier. But obviously that has clear knock-on effects to performance, you know, out on the field and whatever it might be. Another way that I really like to use it, and I still feel like it's undersold, is just simple monitoring and simple assessments, actually. So one of the ways that I've utilised output in this instance quite a lot, working with the British diving athletes that we've got through the university, is simple, almost like a readiness to train check at the start of every session. So dowel, output on the dowel, 5 single counter movement jumps, or sort of squat jumps, if you will, and tracking that velocity over time and trying to then figure out, well, if there's a drop of X%, what does that mean? Now, I'm not for 1 second saying that we have created this model whereby if it drops by 5%, I knock off three reps, or I knock off 5% load. It's not that sophisticated. And I don't think readiness to train really is that sophisticated. What it does do, though, is it sparks a conversation with me, the athlete, and potentially the head coach if they're there, to say, right, well, what's been happening this past week? Have they had a particularly tough week in the pool? Are they ill? Have they picked up a niggle? Have they not eaten well or not slept well or whatever? And then between the three of us, almost have like this mini MDT meeting to say, right, well, what should we do with the session? Clearly we need to change something because this data is telling us you're not quite at the level that you should be. All right, well, let's knock a set off here, or let's remove this exercise. And it becomes a bit more of a iterative, holistic conversation between those key stakeholders, but an important one that needs to be flagged up, that perhaps, again, it's that objective versus subjective element. You know, we could do readiness to train questionnaires, but, you know, we're all familiar with some of the challenges with those types of questionnaires in terms of a true sense of that subjective understanding with oneself, and then the potential of not giving a valid answer to some of the questions for whatever reason. Objective velocity data gives us that at the start of the session. It's really quick to do and allows us to then make those more informed decisions as to how we might manipulate and change training for that day. But the other way I really like it, and it kind of goes back to one of the first points that I made around the whole requirement of 1 hour in prediction, is What we could do with measuring velocity is we could simply pick an arbitrary load. It could be based off a percentage of 1RM, or it could just be let's do 80%. Let's do 80 kilograms, or let's do 60 kilograms in this exercise, and let's measure the velocity at that load. Then we'll implement an intervention, and then let's retest that same way. And just by simple physics, if we take the force equals mass times acceleration equation that is drummed down every student's throat at university, that I do that myself, we know that mass is fixed. So the load, the system mass, the load on the bar, and the individual, most likely, isn't going to fluctuate that much across the 6 weeks. So we'll take the mass as fixed. If we therefore increase velocity is a derivative of acceleration, we've increased the A part of that equation. So if that side goes up, then the F side goes up, which is force. Force underpins strength, and by virtue, we can have a pretty good idea of strength improvements off the back of an intervention. And we could probably then start to calculate what that means from a 1RM perspective. So how much does that actually impact 1RM? And it's a real simple method. It's really easy to do. It's one repetition, or maybe 3 repetitions for reliability, on one load at the start and end of an intervention. And it takes away, again, some of that fear factor that you can often find within the applied world around doing 1RM testing. We don't want to do that. It's invasive, and it could create some issues and blah 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 blah. Well, there's a clear option there, and it's something that I think would work really well in those environments whereby you've only got 45 minutes and you've got a squad of 15 players and you see them twice a week, and you have to really maximize your time, but you still want to do some kind of strength assessment. Yes, we can do jump testing, but it's at the very, very fast end of that force velocity curve, and I don't think it gives you that true reflection of strength capabilities. We can map improvement, but we maybe don't know to what degree. And I think that simple method is one that could be it could be utilized a lot more than my understanding of it being done so.
That's something that I think I started doing a long time ago, where I would just, on something like a squat or bench or whatever it is, a big exercise for people, I would plot that. But I think more recently in rehab, I've just sort of thought I can do that per limb, especially if it's an exercise that's not kinematically too messy, where there's not too much variance in movement. So if you're using machines, again, it's an easy way to do it.
Yeah.
But where even just on my iPhone, on Excel or Apple Numbers, I've just got a pre-drafted template where I can plot the numbers, and then I can very quickly compare left v right and see, perhaps one limb is a slightly steeper curve, one is more shallow, more velocity heavy. Sorry, not heavy, more velocity focused.
Yeah.
So I can see if, like, left v right, how is this athlete compared in terms of their potential to create high force, slow speeds, or lower force, high speeds. And also then what's just the overall curve? Is it shifted outwards in every direction, showing a much better capability? So I think borrowing that ideology, I think, is, whether it's rehab or performance, I think limb for limb can be a really valuable thing too.
Yeah, absolutely. Yeah, there's a lot to be said for. The reason I like velocity is because it kind of has in my opinion, and I would say that the underpinning mechanical principles of human movement support this, is that it has almost like a clear link with neuromuscular function. If you think about, again, that F equals MA and the impulse momentum relationship, all of those center around force and velocity. They're the main two mechanical variables, if you will, that underpin how we move. And therefore, if we can really easily measure velocity, which is 50% of that kind of equation, then we've got a real kind of close relationship with what might be happening from a neuromuscular perspective. And yes, it's all inference. I understand that we're not measuring neuromuscular function, so I am all the time I'm suggesting that this is what I think's happening, but I feel like there's that close link to neuromuscular function that I think you don't necessarily get from a readiness to train questionnaire. You don't get from a jump assessment if it's not on a force plate and you're only looking at jump height, for example, or even ground contact time or something where strategy might have a bit more of an impact on that outcome measure, whereas velocity seems a bit more ingrained in that kind of human movement, which again is why I really like it, and kind of links back to what you were saying there in terms of the asymmetries that we can then try and tease out, and we can say, okay, well, if there's a velocity asymmetry, then perhaps there is a real asymmetry within that neuromuscular system. Whereas if there's a jump height asymmetry, well, have they just not jumped the same way off either limb, and therefore that the discrepancy is potentially more subjective than perhaps it would be if we use something like velocity.
Have you played around with sort of like the center of mass displacement and sort of used the accelerometry just to look at stability, balance, those kind of features? Is that something you've played around with much?
Not really, no. I would say that, my main experiences have been more from a performance perspective, so any kind of profiling or testing or feedback that would feed directly into getting more out of them in that particular session or over a longer period of time. So no, it's not something I'm particularly familiar with.
Yeah, I mean, if anyone's listening and they are, I'd be very keen to speak to them just to see how they're using it. It's something I've just been playing around with recently, seeing, I guess almost like you were saying with the neuromuscular stuff, like you're using these tests and tools to make theories and guesses that are smaller, that get you closer to what you're trying to understand, I think. And I think for me, these tools could be used for that in balance or stability, where we'll do these balance-based tests, especially for things like ankle, where we're judging the ankle stability based on whole system stability and center of mass. And I don't always know how fair that is, because the potential to compensate is so great. And whether this is good or bad, I don't know. So I'd be open to anyone's feedback, especially yours, of like attaching the device to the joint segment that I care about. So if it's the ankle, why don't I put the sensor on the midfoot or something close to the ankle, do the same balance-based task that I might be testing more systemically, and see, do I get much localized instability one side versus the other rather than system instability?
No, that makes sense. I mean, it would be really cool to have a number of devices and almost try and isolate out each limb or joint and see if you can figure out where the instability is coming, as opposed to it being, like you said, system. I mean, it's something that, again, I know you can do in output. They've got kind of an angular velocity setting, and something that again is on kind of a long list of research projects that I'd love to do is looking at and it might have been done once, maybe, actually thinking about it, but looking at the load angular velocity relationship. So, if you're looking at a squat or a deadlift, putting the device around the kind of the quad and the hamstring to look at that limb velocity through that full movement, and just more so to see if it creates any more stability in the actual data that we can get. Because we kind of, when we do that profiling and that approach with a barbell, there's a number of factors that, again, create variability in the data, like for heavy loads, and you might have some whip if you're using a weightlifting bar. If you're using a powerlifting bar, less of an issue, but then you can kind of look at different techniques that someone, when I was doing my testing for my PhD, you would have people squatting in completely different ways. Some would drive up to the top, come up onto their toes and almost shrug the bar a little bit. Others would snap the hips through, so you kind of feel like that was more of a hip drive, and perhaps therefore their velocities were stunted a little bit because the bar wasn't accelerating as much as that person that's really driving the torso and the up onto the toes and into a much more higher position. So by isolating out that limb, the main driver in an exercise like the back squat. Does that create a more stable profile and a more reliable one, or valid, or whatever you're looking at? So, yeah, I think that idea is a cool one, and I kind of see your thought process with it.
It sounds like more of a kind of what you're describing there, more of like kind of valid quality control, doesn't it,
Yeah.
for movement strategy?
Yeah.
And I've felt that in myself, where I've done, I've tested on myself a regular back squat, and then I've looked at using a box to standardize my depth on a back squat when I've been trying to hit velocity. And it hasn't always correlated as well as I thought it might, because I just end up squatting for the box.
Yeah.
And it's just, rather than squatting as I know I should,
Yeah.
because you just try and cheat the test.
Yeah.
It's just human nature.
Absolutely. Everybody wants to do better, whatever, no matter who you're competing with, whether it's your mate or yourself or whatever. You always want to get a little bit better, and human nature is to find a way to do that.
I'm aware of time. Where's the best place for people to kind of find you? I guess the work that you're doing, and if you are active on any social channels, which ones are you best at using?
Yeah, I suppose X is probably the most common one. So that my handle is at Steve381. ResearchGate, my research is up there. I think it's just Steve Thompson or Steve W Thompson, but I can pin that across to you to put in the show notes or whatever. And then happy for people to reach out and get in touch via email. I'll pass that on as well, and if anyone wants to have a chat or have any ideas or collaborations or whatever it might be, please reach out and we can go from there.
Cool. Well, mate, thank you very much for your time, and great to learn more from you today on all the topics discussed. And thanks for coming on.
Pleasure, Andy. Thanks very much for having me.
Cool. I'll stop there.